Last time we had started section 1.3. We were working through limits and continuity. We talked about two ways of finding limits. Do you remember what they are? Two ways of finding limits so far. Graphically, very good. That was the first one. And numerically, those are with tables. That was the second one. And we have one more way that we're going to look at today, and that's algebraically. Now, we had seen an interesting example last time. Actually, it was this one, where it was right here, where we had said, okay, we're going to numerically determine the limits, and take a look. When we numerically determine this limit, this one was actually 6, but then when we did this one over here, we actually found that it does not exist. All we did was change the sign, and we said, isn't that interesting? And we talked about in class what was probably happening is there's an asymptote there, and so we talked about also, somebody mentioned, I think it might factor and simplify. And that's exactly right. So we're going to take a look then at algebraically determining the limits. Whoops, I didn't mean to do that. Let me try that again. For a function. All right, so to algebraically determine a limit for the function, the goal is, you can write this down, big bold letters somewhere, the goal is to plug the number in. Isn't that fantastic? So the goal is to plug in 3 for t on the first one. The goal is to plug in 3 for x on this second one. And the goal is to plug in 3 for x on the third one. I don't know why they're all 3s. They're not always all 3s. Okay? But the goal is to take that value and actually replace it for the variable. So we actually try to do that. And if we can, then the answer is our answer. And if we can't, then we start asking ourselves, what else can I do? So if I were to take the very first one, part A, and replace the t with 3, what will happen? Yeah, okay, I plug in the 3 and I get 12 minus 5, which is 7. And I'm done. No graphs, no tables. That's easy, right? So that's the first thing you should check. If it says algebraically to figure out your limit, see if you can just plug it in and if it will work. And if it does, you're done. Let's try it again on the second one. What happens when I take the number 3 and plug this one in, or plug it in for this x? I get 0 on top and 0 on bottom. And that's not okay. In particular, the 0 on the bottom is not okay, right? 0 on the top is not a problem, but the 0 on the bottom is a problem. So if I get one where it's 0 over 0, like it's a 0 in both locations, what that means is it means that the original function was able to be factored and simplified. So we're going to go backwards now. We're going to do that. So taking a look at x squared minus 9, how does x squared minus 9 factor? Yeah, it's a difference of squares. It's x plus 3 and x minus 3. And the denominator is already a monomial. It doesn't factor. It's in simplest form. So it just gets rewritten. And what do you notice? Yeah, there's some canceling that can happen, right? So the x minus 3 in the numerator will cancel with the x minus 3 in the denominator. Now, until I plug in 3 for x, I have to write limit. So I'm going to write it one more time just to clarify that this is the same thing as what I was looking at before. The limit is x approaches 3 of x plus 3. That's what this problem has sort of boiled down to. That's it. Can I plug 3 in now? Yes, I can. Now I have 3 plus 3, which gives me 6. So if I have the ability to cancel out, give me just a second, the 0 over the 0 like this, if I have that ability to cancel it out and then plug it in, do you remember what is happening in the graph when that's the case? Okay, there's a hole. I have a hole in the graph. There's one location on the graph where I do not have an actual point, and it's at the x value of 3. Yes, your question?
I was just going to ask, is it only for 0 over 0 that you know when to go back and factor?
Yeah, it is. If you do not get a 0 over 0, next question will be like that, then you'll know it can't factor.
Okay.
Yep. So 0 over 0 is the red flag. I know this can factor because I got a 0 on the top and a 0 on the bottom. This one, if I try plugging in 3, I've got 3 squared plus 9 on top, 3 minus 3 on bottom. What do I get? I get 18 on top, that's right, and 0 on bottom. Again, the 0 on the bottom is the problem, but because it's not 0 on top and 0 on bottom, it's not going to factor, it's not going to simplify, and I'm not going to be able to continue with the problem. So when I get a number on top that's not 0, and a number on bottom that is 0, then this means that this limit does not exist. And it means that I have an asymptote there. That's what's happening. You see, you can get infinitely close to a hole, correct? There's a hole in the graph. I can get as close as I want to that hole in the graph. But if I have an asymptote, it's a not great picture, but you have an asymptote right here. It's going down the middle here. There's no way to get close to any specific y value because one side is going to infinity, the other side is going to negative infinity. And even if this isn't the picture, then something like this might be. And again, there's still not a specific y value that you're approaching because they're getting infinitely large still on both sides around that asymptote. Make sense? All right.